Interfaces are really closely related to inheritance and partially come out of a misuse, if you will, of inheritance hierarchies that sometimes happens by designers. So sometimes we use inheritance kind of as a convenience to reuse things without necessarily have to rewrite code or whatever. So, for example, we could define a mower class, and so we have some cost to mowing, and then we have some, um, the main functionality is to trim grass, and we know. This is what a typical lawnmower looks like, but you can go fancy and you can get yourself a riding mower, or you can maybe go less fancy and have one of those push mowers out there. Obviously, a little bit more work by the human, but certainly a lot cheaper to go off and buy a mower. We also, if we want to, trim grass, if that's our main focus, we can also get one of these things. A little fleet of goats or cows or you know something like that that'll eat grass. So they're technically a type of mower, but are they? Remember that is a relationship. The first three absolutely are mowers. That's their only function in the world. The fourth one can function as a mower, but that's not what it is fundamentally. And so interfaces provide us a way to plug into a service without having to be really aware of the source. So, like in the example we're talking about the abstract classes, the plug out there, we can plug into power plants or hydroelectric dams or wind turbines or a person on a treadmill. But that person on the treadmill does not have to be a electric generator for us to be able to get it. It's a service that's separated from the source that's out there. So the idea of an interface is an interface defines a role that something plays. So when we see this swimmer interface here, we can see that, okay, well, submarines and whales are both swimmers. They both have that behavior to swim. You might not think of a submarine as swimming, but that's essentially what it's doing, right? But fundamentally, a male is a mammal, and it allows the whale to both be a mammal and a swimmer. There's certain types of mammals who swim, but not all mammals swim, right? This is important because a lot of programming language do not allow you to inherit from more than one thing. It's called multiple inheritance, and there's a few that do, and there's some rules around it how you can make it happen. But there's some really quick problems that come up when you do that because you think about it. If I have a parent that defines a behavior called weight, an attribute called weight, and another behavior that also defines weight, but one of them is weight of me as the object, and the other one is the weight I can carry. I mean, obviously, I could rename that variable to be something different, but then it becomes confusing of which weight is it? My weight or the weight I can carry. And when you get into behaviors, it can be confusing that way as well. But interfaces basically are saying like, okay, well, we're okay with that as long as things are named the same. They're probably the same concept. Now, before we go into that, interfaces in UML are one of three things. There's this first one here. This is called a lollipop. It's a circle with a stick on it, and sometimes the circle is given a name of the interface. Now, I don't know why they came up with this, and I don't find it to be terribly useful, but you see it from time to time. Or you can define an interface with a stereotype, where you put, as I said, in the greater than less than in between there, the word interface. And typically they're also italicized to look abstract because I can't create instances of interfaces. The other way you can tell of interfaces is when you have the dotted line with the inheritance triangle on top. So when I inherit from something with a dotted line, I'm implementing an interface. Now, interfaces, the primary use of them is to define a set of behaviors that that describe the role that the interface is doing, like swimming or hunting or being a list or a set or a map if you're talking about data structures in programming languages. But interfaces also can serve as a type. I can have, for example, in this case, an array of swimmers. I could have whales and submarines and scuba divers and seabirds who sometimes swim a little bit as they dive underneath for fish. So interfaces can help me organize data as well in a way that's saying that, okay, well, these are not all the same objects, but they all play the same role. I can have a group of swimmers that I'm going to take out for a swimming test out in the pool to make sure they can swim. Okay, well, the whale and the submarine might not do well in that swimming test, but hey, they could do it, right? They are swimmers. Um, The great part about interfaces is they're kind of lightweight. I get to have behaviors. I get to have tagging them with information and grouping things together without having to do more than just say, "Hey, these are the behaviors I want it to do," or perhaps no behaviors at all. I can use interfaces without behaviors just to tag things, which means that interfaces can actually be hierarchical as well. An interface can inherit from another interface in many programming languages, Java specifically. Um, so I can have a swimmer and a specialized version of a swimmer called an underwater swimmer, and a specialized version of an underwater swimmer called a underwater hunter, which also implements the predator interface. So interfaces can extend to other interfaces, but classes must implement interfaces. There's a little bit of some difference inside there. So the main difference here is the ISA rule applies to inheritance. A thing has to be a class and is always a class, at least within the context of the problem you're trying to solve, to qualify for inheritance. Where interfaces is just simply a role something plays at a moment in time. You right now might be a student. I right now am a teacher, but that's just something we do at this moment. And in the future, we could be colleagues, or you could be my teacher, and I could be learning from you as a student. So things that change dynamically over time is just a behavior that's part of what you are is something that gets thrown into an interface rather than inheritance.